Okay, so now we're dealing with part C. Part C reads P. P is a point on the edge BC, which is located at a true distance of 55 millimeters from the point B. We're asked then to draw the plan and elevation of a line D to P, and then determine and indicate the true length of the line DP. Okay, so to start off with the first bit, we're looking for P, and P is 55 millimeters of a true distance away from B on the line BC. Now, that means we need to get a true length of the line BC. So we don't have a true length of BC in elevation, nor do we have it in the plan, but when we projected perpendicular to BC to get our true length, you'd see I've already marked the true length of BC here. And if it's 55 millimeters from B, just measure 55 mil down, but you must be measuring this on the true length. Here it will not work. And that is my point P. Okay, so I've located the point P in this X1, Y1 auxiliary. So now what I can do is I can project that point P down to the line BC in plan. So again, I have this adjustable set square set up to that angle already. So projecting P, again, it must be to the line BC because the line P is on the line BC. So there is P. And again, just bring it up into elevation to the line BC. And there it is. So I have P located in plan, and I also have P located in elevation. Next thing I have to do is draw the plan and elevation of the line DP. So, quite simply, once you have P located, there is the elevation of the line DP, and there is the plan. That's the plan of the line DP. So the second part to C is we're asked to indicate the true length of the line DP. So what I like to do with this case here is rebat it. Okay, so I'll use a yellow construction line for this. So I'm going to use P as the fixed point, and I'm going to rebat D down to be horizontal away from it. So if I want to get a true length of something, the easiest way to get a true length of it is project perpendicular to it. So I could project perpendicular to the line DP and create a new auxiliary view and use the distances from two views back. Or the quickest way, which I'm going to do now, is to rebat the line. So I'm going to fix the point P and leave it in its current location. And what I'm going to do is rotate D about P until it's horizontal. Okay, so D is now being rotated about until it is in the horizontal location. Now I'm going to highlight or harden that in as in the dashed position. Okay, so this dashed line represents what DP looks like in the rotated position, and I'm going to label that as point D1. So as D is a ground point, D1, I've only just rotated the line, I haven't raised the point D, so D1 will be at the same height as D was in elevation. So I'm going to project D1 straight up. So this is the location of D1 in my elevation. So as I said, P is fixed, P hasn't moved. I've rotated it now, so D1 to P is horizontal. Therefore, the line D1 to P, because it's horizontal and I'm looking perpendicular to it in this view, this is a true length. So P to D1, this is a true length of that exact line, which is a true length of the line D to P. So I'll just mark that in as TL. That's a true length, and therefore that's the solution to part C, part 2.